Hello everyone, myself Mr. Kiran S. Chinswalkar, lecturer in Mechanical Engineering Department from Praveen Patil College of Diploma Engineering and Technology. Today we start 5th chapter Joining Processes Part 1. Learning Outcomes. After watching this video, you should able to know different welding processes. Second learning outcome is different types of weldings, and third is different types of welding flame. Now we see what is a welding processes. Point number 1. Welding is a process of joining two similar pieces of metal by means of heat and applying pressure. Point number 2. The heating of metal increases the temperature of fusion state, and to complete the weld, pressure is applied. Point number 3. In case if no pressure is applied, then additional filler material is added to welding joint. Point number 4. Welding is extensively used in a machine structure assembly of automobile, shipbuilding, and many structural works. Now we see different advantages of welding processes. Point number 1. The welding joint can be made stronger than parent metal if filler metal is used, and it has a superior properties. Point number 2. With concern of welding, there is no need of any kind of mold, pattern, etc. Point number 3. Fabrication with welding result in lighter construction, and there is a saving in a material also. Point number 4. It is possible with welding techniques to add the specific material with desired characteristic to any portion of the machine parts. Point number 5. In general case, the welding equipment are not costly. Point number 6. Designing of welding fabrication is not so tough. Point number 7. Welding can be mechanized. Point number 8. A wide range of metals and its alloy or dissimilar metal can be joined by welding processes. Point number 9. Welding joining of metal is performed in any position, so there is no need of any kind of special construction. These are some advantages of welding processes. In this slide we see different disadvantages of welding processes. First disadvantage is ultraviolet light are very harmful for health produced during the process, and also fumes and spatters. Point number 2. Edge preparation should be prominent for good weld. Point number 3. A skilled welder is required to produce a good quality of welding joints. Point number 3. A residual stresses and distortion is occur. As a result, workpiece may damage. Point number 5. After welding, stress relief is required. Point number 6. During heating, the metallurgical changes occur in the weld filler metal. Due to this reason, the molecular structure of a base metal is different from filler metal. Point number 7. Jigs or fixtures are required to hold the weld workpiece. Now we see types of welding. Welding process is broadly classified in two groups. Group A, plastic welding or pressure welding. In this method, two surfaces of metal to be welded are heated to plastic state and then forced together by external pressure. The process does not require additional metal for completing the weld. Various pressure welding processes are: first is a forge welding, second is a resistance welding. In resistor welding, there is a subtypes. First is a spot welding, second is a projection welding, third is a seam welding, and fourth is a butt welding. Then second part of classification of welding is a fusion welding. In this method, two surfaces of metal to be joined are heated to fusion or molten state and allowed to solidify. Additional metal is generally supplied by filler rod to complete the welding joint. In this process, no pressure is applied. Various fusion welding processes are: first is the arc welding. Arc welding, point number A, gas shielded arc welding. This is subdivided in three types. First is the atomic hydrogen arc welding, second in tungsten inert gas arc welding, third is the metal inert gas arc welding. Point number B, flux shielded arc welding. It is subdivided electro slag arc welding and second electro gas arc welding. Next is the unshielded arc welding. Unshielded arc welding is divided in carbon arc welding and metal arc welding. Then second point, electron beam welding, and third is the oxyacetylene welding. Special welding processes: first is the thermit welding, second is the friction welding, and third is the ultrasonic welding. Now in this slide we study the gas welding. Point number 1, gas welding includes all the processes in which gases are used in a combination to obtain the hot flame. Point number 2, the commonly used gases are acetylene, natural gas, and hydrogen in combination with joining processes oxygen. Third, for metal thicker than 1.5 mm, additional metal called filler metal is added to weld in form of welding rod, which is made of similar metal as their parts to be welded. Point number 3, flux is used to remove impurities and oxide on two surfaces to get a satisfactory bond. Point number 5, flux is used in the form of dry powder, paste or solution, or as coating on welding rod itself. Now we see oxyacetylene welding. Point number 1, in oxyacetylene welding, the joint is heated with the flame obtained from the combination of oxygen and acetylene with or without use of filler metal. Second, the blue flame obtained produces a temperature of 3200 degrees Celsius. Point number 3, carbon dioxide and water vapor formed by combustion of gases envelop the metal to be welded, reducing oxidation of it. There are two types of oxyacetylene welding. First is the high pressure welding, second is the low pressure welding. Now we study oxyacetylene gas welding, and type is high pressure system. Both oxygen and acetylene are used for high pressure cylinder. Oxygen cylinder are filled to a pressure of 125 bar and acetylene cylinder is charged with pressure of 15 bar due to explosive nature of acetylene. Pressure regulator is fitted on the cylinder for adjusting the working pressure of welding. In general, the working pressure of oxygen required for welding and cutting is 0.35 and 3.5 bar respectively. Acetylene cylinders are filled with a porous material in the form of charcoal, cement, and saturated with acetone, a liquid which has property of absorbing 25 times its own volume of acetylene. Acetylene is compressed into this cylinder to a pressure of 16 to 20 bar so as to dissolve into acetone. The cylinder containing oxygen is painted black from outside and that containing acetylene is painted in maroon color. Two pressure gauges are fitted, one indicating the gas pressure in the cylinder and other reduced outlet pressure. Generally, the working pressure for welding and gas cutting varies from 0.14 to 0.21 bar. In this slide, we study the types of welding frame. The types of welding frame, first is a neutral frame. The neutral frame is, you can see in this slide, at the below of this slide there is a picture of neutral flame. First point, it is produced when oxygen and acetylene are supplied in nearly equal volume to the torch. It has two zones, a sharp brilliant cone extend a short distance from the tip of torch, which develop heat at temperature of 3200 degrees Celsius, and an outer cone or envelope faintly luminous and lot of bluish color protects the molten metal from oxidation because it consumes oxygen from surrounding atmosphere. Neutral frame is widely used for welding steel, stainless steel, cast iron, copper and aluminium. Second type of flame is oxidizing flame. First point, the oxidizing flame is shown in the figure. First point, the flame is produced by supplying excess of oxygen. Point number 2, it has two zones like neutral flame, except that the inner luminous cone is not sharply defined and is much shortened and has a purplish tingle. Point number 3, the outer envelope appears to have more color. Point number 4, the oxidizing frame is used in a fusion welding of brass and bronze but is not desirable for steel, as it will result in a large grain size and more brittleness with a lower strength. Next frame is a carburizing frame. The flame is produced by supplying excess of acetylene. It has three zones. First zone, a sharply defined inner cone. Second, an intermediate zone of whitish color. And third, a bluish outer zone. The length of intermediate cone is an indication of the proportion of the excess acetylene in the flame. In welding, it gives higher carbon content to the weld, resulting in a hard and brittle weld. Now we study carbon arc welding. Point number 1. In this process, carbon rod is used as a negative electrode and work being welded as a positive. Point number 2. Since the polarity is fixed, DC supply is used in these processes. Point number 3. Carbon arc is used as a source of produced heat. The temperature produced by arc at a positive electrode is 4000 degrees Celsius and at negative electrode temperature produced is 3200 degrees Celsius. Point number 3. This high temperature melts the base metal. Point number 5. Filler metal in the form of rod is supplied as additional metal. Point number 6. Protection of weld metal is obtained by forming slag into weld. Point number 7. Carbon arc welding is used for welding cast iron, steel, copper, bronze and aluminium. In this slide, we study shielded metal arc welding. Point number 1. Shielded metal arc welding is a process which melts and joins metals by hitting them with an arc between coated metal, electrode and the workpiece. Point number 2. The electrode has an outer coating called flux that assists in creating the arc and provide the shielding gas and slag covering to protect the weld from contamination. Point number 3. The electrode core provides most of the weld filler metal. Point number 4. Art is started by streaking the work with the electrode and quickly withdrawn it to a shorter distance. Point number 5. Electrode end is melted by intense heat and transferred across the arc in the form of small globules which are deposited with the fused metal. Point number 6. When the metal has been cooled, a solid union is formed between the welded parts. Point number 7. The welding power source provides constant current and may be either alternating current or direct current depending on the electrode being used. The best welding characteristics are usually obtained by using DC power sources. I hope you understand this presentation. Thank you.